Welcome to my YouTube channel Mechanical Magic Mechanical Learning Tutorials. So in this video I am talking about some of the calculations on the basis of a diesel cycle. So let us see the data which will be given for the problem on diesel cycle. The compression ratio of an engine working on a diesel cycle is 15. The cutoff takes place at 12% of the working stroke. The air is drawn into the cylinder at 100 kilopascal and 27 degrees centigrade. Assume Cp, that means specific heat at constant pressure, 1.006 kilojoule per kg Kelvin, and Cv, that means specific heat at constant volume, that will be equal to 0.171 kilojoule per kg Kelvin. Calculate first temperature at the end of compression, pressure at the end of compression, and last one, air standard efficiency of the cycle. Says from the given data, let's see which kind of data is given to you. So the cycle is diesel cycle over here, and the compression ratio, it will be given 15. So compression ratio representing as R is equal to 15. Then the initial pressure is given to you, so that will be P100 kilopascals over here at the temperature T1 27 degrees centigrade. So finally P1 equal to 10 raised to 5 Pascal and T1 that will be equal to 300 Kelvin. Two more data is given to you. Cp 1.006 kilojoule per kg Kelvin over here. Cv 0.171 kilojoule per Kelvin. And finding the value of temperature at the end of the compression, that will be T2, pressure at the end of the compressor P2, and the air standard efficiency of the cycle. So let us see on to the PV diagram on diesel cycle over here. So from the data, x-axis representing as a volume, y-axis representing as a pressure. Says from the diesel cycle PV diagram, 1 to 2 process that will be adiabatic compression process, and 2 to 3 that will be representing as a constant pressure heat addition process. 3 to 4 once again adiabatic expansion process, and 4 to 1 that will be representing as a constant volume heat rejection process, and complete the cycle of diesel cycle. Says from the data over here, 1, or you can say 0.1 and 0.4, so at constant volume process, so V1 equal to V4, and over here P2 equal to P3, and the rest of all the points it will be like P1, P4, V2 and V3. As from the diesel cycle theory, here V2 that will be called as a clearance volume, and V2 to V1, or you can say V4, that will be representing as a swept volume of the cycle. So let's see the calculation part of these problems. So first one, temperature at the end of a compression process. So as from the relation of the Cp, Cv and gamma, so gamma is equal to Cp upon Cv. So you will find out the value of gamma, and that will be 1.4. Now for the diesel cycles, so T2 upon T1 that should be equal to R raised to gamma minus 1. So finally you will get T2 equal to 15 raised to 1.4 minus 1 into 300. So you will get the answer of the T2 from the adiabatic compression process relation of temperature and the compression ratio. So T2 equal to 886.25 Kelvin. So that will be the answer number 1 over here. So you can see that the temperature at the end of the compression process. Now I am interested to finding the second one, the pressure at the end of a compressor. So we have the relations P1 V1 raised to gamma equal to P2 V2 raised to gamma. So finally we have P2 V2 upon V1 upon V2 raised to gamma. So V1 upon V2, that will be equal to the compression ratio. So finally you will get the P2, that the value of P2, it will be 44.31 bar. So that will be the answer of the second questions. Now I am interested to finding the air standard efficiency of the cycle. So as from the air standard efficiency of the cycle, we are assuming that the clearance volume, or you can say VC, or you can say V2, that will be equal to 1 unit over here. There is a certain assumptions. So V1 upon V2, so finally you will get V1, that will be equal to R into V2, so that will be 15 units. Now cutoff takes place at the 12% of the working stroke. So that will be the given data over here. Just you can see cutoff take place at 12% of a working stroke. So from the given data over here, V3 minus V2 divided by V1 minus V2. So that will be equal to 0.12, or you can say 12%. So finally you will get V3 minus V2, the value of V2, we are assuming that will be the 1, and we put the value of V1, that will be the 15. So you will get the V3 over here, that will be 2.68 units. So cutoff ratio, that should be equal to V3 upon V2 as from the diagram. So 2.68 divided by 1, so cutoff ratio, that will be 2.68. Now as from the equation of the air standard efficiency of an diesel cycle, that will be equal to 1 minus 1 upon R raised to gamma minus 1 into 1 upon gamma into cutoff ratio raised to gamma minus 1 upon rho minus 1. So just put the value of compression ratio over here, and that will be 15, gamma, so that will be 1.4, and cutoff ratio rho, that will be equal to 2.68. So just put the value and calculate, and you will get the answer. The efficiency of a diesel cycle, that will be 0.4282, or that will be 42.82%. So that will be the answer number 3. So this is the simplest method to calculating a temperature at the end of the compression, pressure at the end of the compressions, and the air standard efficiency of the cycle. So such kind of questions, it will be asked for the 7 marks questions from the different universities. If you like it, if you understand, then subscribe, share. Thank you very much.